Welcome back, ninth graders. I hope you had a great week. For this week, we are going to be learning about functions and how to evaluate them in a word problem context. All right, so you will need a pen or a pencil. You will need some kind of paper, something to write on, and you need to turn those thinking caps on. Let's get started. A function is a way of describing something that works. If I say this functions, that means that this thing works. All right, but in a mathematical context, a function has a very specific meaning. It is a very specific type of relationship. Now, any kind of mathematical relationship can be viewed as a relation, okay? So any kind of relationship between two quantities, we would call a relation. Now, the notation here is important, okay? So the notation f of x is what we use for a function. F of x means function of x. If I'm looking at, let's say, f of x is equal to 3x. So x could be the number of cookies I have, and f of x could be the total cost of my cookies. Now, if my function is f of x is equal to 3x, what do you think that means? Pause the video and take a second to figure that out. All right, what do you think? 3 times the number of cookies should give us what the price is for each cookie, right? So if I have 10 cookies and each one is worth $3, then the total price of my cookies will be $30. An important thing about these functions is that there is only one output for every input, okay? So only one output for every input. Now, let's think about why this might be an important type of relationship. Let's suppose someone is trying to deliver shawarma to you. The relationship between where they think the individual is they know that the individual is 5 miles away from them. How many outputs do you think are 5 miles away from an individual that is at a restaurant selling shawarma in the middle of your hometown? Well, there are certainly more than one, right? There might be 2, there might be 5, there might be hundreds of houses that are exactly 5 miles away from this restaurant. So why would that be a problem? Well, if the shawarma delivery person is trying to find you, they're not going to find exactly your house, right? Because there are going to be multiple houses that they will have to go before finding you. So that is why a function is important, because it gives us exactly one answer, one output to deal with for a given input. All right, so now we're going to look at different types of functions and their graphs. This is a linear function, right? We've seen this before, right? We've called it a linear equation. What makes it a function is that there's only one output for every input, every x value. All right, now taking a look at this function, what type do you think it is? I'll give you a hint. It is a type of polynomial function. So pause the video and give it a try. Actually, it is a quadratic function. What about this one? Another polynomial? This one is a cubic function. It's a cubic function. How would you have known that? You can look at the difference between the f of x values and the x values. So when x is 1, f of x is 1. When x is 2, f of x is 8. When x is 3, f of x is 27, right? So that should help us figure out that it is cubic. All right, we've got our last 2 functions here. So what do you think this function is? It kind of looks like a quadratic. It's something we went over in one of the past videos. It is exponential, okay? So when you have a value of 0, the function is equal to 1. That's your hint. And it never goes negative. It plateaus, right, at 0, which makes sense because we know even when we have a negative exponent, we know that our output just becomes very, 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 very small. And finally, we have the inverse of the exponential function or the radical function, right, as we can see it trailing off like this. So I want you to soak all of these graphs in. You can pause the video, rewind, and ask yourself, what are the obvious differences between these functions? How could I spot them in an instant? Also ask yourself, what situations would I find an exponential function? What situations might I find a linear function? So Now that you've identified what a function is and the different types of functions and their graphs, it's important for us to move on to the next phase, understanding functions in the context of a word problem and how to evaluate them. So here are some basic tips for when you encounter any kind of word problem. The first thing is you want to find out what you are looking for. What is the value that you are trying to find? Okay. If it helps, write a word equation. So this would be taking the word problem and taking the values that are involved. So maybe we're talking about oranges and the cost of oranges. And so if you know that the price of oranges is $3 for every orange, and that gives you the total cost, then you can set up a equation, a word equation, which is 3 times the number of oranges equals total cost, and you can write it out that way. Now your third step would be turning those words into variables. Identify the operations involving specific words. So for example, if I see that Johnny had 4 apples, Sally had 3, and Jimmy had 4, how many do I have in total? We know that and represents addition. So we'll take a look at the words and their associated operators in a second. The final step is to evaluate the word problem by plugging in an argument, a value for your independent variable, or x, in order to find the output value for the function at that point. Here you can see some of the operators and their associated words. Go ahead and pause the video and jot some of these down. So let's take an example. A park charges $10 for adults and a $3 tax regardless of how many people are involved. How much will it cost to be admitted if 3 adults want to get into the park? So for this problem, we can start off by finding out what is the unknown. What are we looking for? So we're looking for the total cost. And so our total cost can be written as f of x. And so what is our x here? Our x is going to be the number of adults. So if we were to write this as a word equation, we could say the cost is equal to 10 times the number of adults. And the reason we know it's times, if we are looking at our operator, is because there is a $10 cost attached to, or we could even say mapped to, each adult. Finally, we see that word and represents addition. So the and is going to be 10 times x plus 3 is going to equal f of x. Finally, we have to evaluate the function based on our value for x, which we know is 3. And so we can do 3 times 10, which is 30, plus 3 gives us a total cost of 33. All right, now we're going to do one more example involving quadratic functions. A picture has a height that is 4/3 its width. It has an area of 192 square inches. What are the dimensions? So for this one, we can direct ourselves to the end of the question first to figure out what we're solving for. We're solving for the dimensions, or the lengths of the sides of this shape. And so the shape we're dealing with is some kind of rectangle, because the height and the width are different. Now we're given one side of the equation, the area, which would be 192 square inches. We're also given the relationship between the height and the width. So if I were to try to find area, I would normally multiply height and width. The only issue is in this problem, I don't know the height and I don't know the width, so I have 2 unknowns. Well, when I have 2 unknowns, I actually have to set up a second equation. My second equation is going to be the height is equal to 4/3 the width. And so I can now plug in the 4/3 w for my h variable, and now I only have one variable. So my new equation becomes 4/3 times w, which can be rewritten as 4/3 w squared is equal to 192. Finally, if I want to solve this, I'm actually evaluating it backwards. So I have the right-hand side of my equation. I have my function, which is the area, but I'm looking back to find what are the input values. So I can divide both sides by 4/3, which is the same thing as multiplying 192 by 3/4. That gives me 144, and then I take the square root of both sides, and that means my width is going to be positive or negative 12. And we know that you can't have a negative size for your width, and so the answer has to be 12. Finally, if we want to find the height, we can do 4/3 times our width of 12, and that'll give us our height, which would be 48 divided by 3. 3 goes into 4 one time, and then 3 goes into 18 6 times, so our height is going to be 16. Alrighty, so in conclusion today, we have looked at what a function is, how it compares to a relation, the different types of functions, as well as their graphs, and how to solve a word problem for a specific argument. In other words, how to evaluate a function in a word problem. So, don't forget, this is a 9th grade competency. If you want to move on to the next level of math, you need to master this skill. Finally, have a great rest of your week and check for a quiz on the Google Classroom. See you next time.